floral welcome. I request Mrs. Shilpali Basu, actually AID's department from AC College of Engineering, to give a floral welcome to Dr. Kumar. Doctorate from electronics and communication from University of Delhi in quantum computing specialization. Currently, he is also working as the founder and director for Team Quanta LLP at Bihar, India. Founder and president of FDPRAIT, New Delhi, India. He has been an associate professor and into DTC Greater Noida and served in various institutes like NSUT New Delhi, IIM Greater Noida, and NSUT again New Delhi, and also MRC Faridabad. He has published various research papers in international retreat journals, conferences. He has got many awards as well. To name a few, he has worked in various like South Korea in various quantum computing projects and under the development of metaheuristic quantum algorithm for vehicle path optimization problem. Also in the collaboration with Quantum Maritime Research with Quantum South Railway and Forest India. He has various industries collaboration with Professor Chan Book, Director MEMLT with again GIST Korea, Dr. Satish Kumar in USA, representing in Saudi Arabia, and he has been a reviewer in various scientific transaction journals and communication letters as well. He has taught many courses, basically so belongs to electronics and telecommunication domain, so he is the right person to guide us in the domain of quantum computing. Sir has got many patents as well, and he is being very instrumental in his research work and has received awards like Excellent Research Award, Global Education and Corporate Leadership Awards from that is in India Merit. Again, Best Startup India Initiative Award during Golden Jubilee Midterm Symposium of IET 2019, Young Scientist Award, Engineering, Science and Medicine, Coimbatore, India, then Best Entrepreneur Award, Best Angel in India. So Sir has received so many awards. So it's really a privilege for all of us to listen his words of expertise in the domain. So with this, I would like to all of us to give a huge round of applause. And so if I have missed something, please come with that.
like this and screenshot
It's okay? Yeah.
Yeah, it's better. Okay, yes. Hello? Sorry? Thank you so much. Sorry, fine. My sound is okay? Yes. Okay. Thank you. Yeah, my sound is I think. Yeah. That's all. Thank you. Thank you so much. It's a great pleasure for me to come here from the south, from Delhi to Mumbai and Mumbai to Mumbai. So, as I managed to many things and all, I think it's just simple. Okay, and I'm also saying like you, I'm an engineer. I did my engineering, BTech from electronics, MTech from electronics, and PhD from electronics branch also. But because of my supervisor, I started my journey with quantum. And when I started my journey as a quantum, literally I was zero from one. So, as an engineer, what exactly and how I start, why I came here, because literally I want to collaborate. I came from the South Korea last year before. And why I came here? Because now I completed my project from South Korea. Even they offered me to extend your tenure. But I denied and I decided to know. I come back to India and let's connect with many people. But exactly I learned from the beginning, like old school guy, MATLAB to Python, Python to QScript, QScript to Quasar, Quasar to many others. Okay, and frankly I'm boldly speaking. Curious, I certainly started my curious as I'm a founder. The second startup is like some other way. But as my dream started as a curious, I started my curious from 2019 when I was completed 2017 at PhD. And then the professor told me that we start some startup something like that. So I was also thinking about how actually and which name is basically this. So I'm also very prone to like interested in the movies and all. Captain America and all this. I was at the time, and at the time was 2 o'clock, and suddenly when slogan was coming, that India and lots of people are actually racing in the quantum. So this word came from that, race. And I put this Q word, the curious. After that, all the Q term, the Q kids see, Q pi, Q this, many Qs come. Iron Q and all, many things like that. So then I extended the Quantum Research Center for Excellence. The name actually the Q. So, story is very simple and all. So I came here how you're actually the mathematical terms to connect your engineering, to connect your simulation part, and when the quantum computer will come. See, this is the real pictures. I developed this one. Okay, and this is basically the idea is continuous. One more thing I want to do. Idea continuously increasing the qubits. Right now, how many qubits? 400 some 33. And if you talk about the arithmetic equations, it is supposed to be 127. So I developed this quantum circuit and to limited qubits. See this is 5 qubits, 1, 2, 3, 4, 5. And I use some different, here I use the read circuit measurement and reduce this one into the 2 qubits. Means there is a limited qubits, you can minimize the qubits and the same the 5 qubits to work into 2 qubits and whatever the applications like intelligence, health sector, security, anyway, you can use that. Okay. So how the motivation basically started from the quantum? So quantum is, as per my concern, what exactly? Quantum is a physics or mathematics? What is that? Everybody is confused. Oh, it's a physics. Sometimes oh, it's a totally mathematics. I said quantum is a mathematical framework. It's It's not a physics, it's not a mathematics purely. It's a mathematical framework. And that mathematical framework is described by wave function. When the wave function came, it's not a physics, it's an engineering. E to the power j theta, something like that. And that wave function described by one famous scientist, his name is Schrodinger. So these two main persons, the real culprit, two started the beautiful what exactly. And before that, almost 123 years completed the quantum. Not everybody is saying this is a new university, it's not a new university. When the Planck started the quantum work in 1900, that quantum started. And they trapped Einstein in 1902. And then 1905, they explained about the wave nature and something. And then after the main scientists, Bohr and others. But these two scientists actually explaining about the quantum and explaining about how the energy is explained. So one is Schrodinger, another is Heisenberg. So I started always from why here because everybody knows the total energy is kinetic energy plus potential energy. Kinetic energy is E square by momentum. And potential is just consider the potential. So both the scientists occupied one by one. So they are talking about the momentum operator like that. And they started from this state. Okay. So both the scientists when they are describing this, the quantum, it is exactly called the interactions like Heisenberg interactions and Schrodinger interactions. Okay. So based on that energy means kinetic energy plus potential energy. Okay. So when the Heisenberg told that if operator means momentum should be varies according to the time and state is constant, it's a Heisenberg interaction. But Schrodinger is totally different. He said, I am not bothering about the momentum. It is very difficult to control the momentum. Momentum means in the three dimensions, px, py, pz. So he said, no. In my case, momentum should be constant. Means operator should be constant. The p square, no, we are not interested about the time taking. We are just considering the potential. Okay. Suppose if any ball is sitting in this air and they are rolling and putting the small breakers, what exactly is the uplifting and go back to the same line. So when the lifting from the zero to some point, that is the energy state. And in technically it's called a disturbance, and in highly technical it is called perturbation. Okay. So my PhD also started from this guy, the Schrodinger. I developed quantum gate based on Schrodinger pictures. All my PhD, all my work till now, I just completed almost 10 years. The Schrodinger interaction picture. My postdoc also started from the same story. Now, but this is also important. Why? Quantum is probabilistic mechanism. Quantum is matrix mechanism. So all the matrix notations in that. Like cat 0 is somehow is 0, 1, 1, 0. Cat 1 is suppose 1, 0. I am sure. Next time. But after later on, this guy, the Feynman, actually described the quantum mechanics. And this guy approached to it's supposed to be 1984 to IBM, and they told, let's start to develop quantum computer. But IBM denied at that time, 84 somehow. No, this is not feasible, and it's not. This is totally hypothetical. But now, what exactly is the main bigger player is IBM to developing the quantum computer. How the story will connect and why the IBM is in the bigger picture, you can understand very easily. I will later on. Then after that, 85, David Dutch, he started some quantum machinery, developing the quantum circuit, something universal. After that, he just showed, still he is in MIT, and he is developing and still is also working in many things and many algorithm factorizations. Brokers, at that time he obviously from the IIT. But suddenly when global search algorithm came, everybody like oh, now finally we got some quantum optimizer. But there is a many limitation behind this global search. First is the complexity, second is order. And when 2022 scientist suddenly came into the picture and got the Nobel Prize based on entanglement. And why I put this year, not physics, it's a chemistry. Right now, he got the Nobel Prize with quantum dots. So it's a journey. It's not like ending here. It's a synthesizing the quantum dots. And we are also planning to develop the quantum computers based on the quantum dots. Later on, I will explain how we actually are associated and what is this. So why they are? These all are actually physicists. These all are some are engineers. These also engineers. And one more is a director. Never I use this pictures and all because it's always totally different. So as I mentioned, my topic is curious is more concerned about the ion trap. Yesterday I saw your engineering ISSR and they are working on photonics and superconducting qubits. Many drawbacks, many things are also good. Okay, easily we can actually establish the quantum computer and development. But if we talk about the fidelity, error mitigations, and supposed to be stability, then again there is a big gap behind that. So this ion trap are supposed to be very soon it will come to the red matter. This is nothing. It's the same family of the hydrogen atom. But why is mentioned the RAIT? Because the putting the ions in the waveguide and all the symbols or all the systems called actually the atoms. Okay, so and the property behind this atom is it's a highly sensitive. So some of the professors from the HRI and some more professors or scientists they are working with some satellite communications and some others because it's a highly sensitive. They are using the quantum information processing. So trapped ion is a very promising approach. I use actual trap ion and what people already published developing their quantum control kit and based on the ion trap. And now next one is the very soon it will come into the picture ion to developing the quantum computer. So they can perform the very low error entangled operations with the ion 14 ion qubits. I used 5 qubits till now. I experimented in South Korea and tested on the OR2 also and it successfully worked. But still there is many limitations. All the systems has a limitation. Whether it will be the photonics, whether it will be the superconductive qubits, whether it will be ND atom, ion trap. But the question is, which one is the more stable? Whether it will be the some ions and we are also working like that. Some amplifier is stable, more stable, some amplifier is not stable. But question is which amplifier is more stable? So same like that, which system is which quantum computer is more stable to take the low error, to taking or to actually to performing with the low error predictions. So the quantum theory is allowing the two or more precisely acting on the coordinated even when they are same states like superposition or entanglement. The two properties and these are actually the basics. And you know that the superposition, what exactly superposition? In mathematics, superposition is actually followed the two things. One is the homogeneity and another is linearity. The same, if you are actually describing the qubits or represented the wave function, it's also like that, homogeneity and linearity. And as for the Bell theorem, the quantum correlation cannot be explained in classical terms. The Bell was actually at the time to explain. The some classical actually not operations on this quantum correlations. So the entanglement quantum system should be one coherent group. This is very important. You heard that every time the decoherence. Why it's happening the decoherence means all the qubits are not entangled, not actually mapping perfectly. That is the main problem. It's a decoherence. If all the qubits are perfectly mapped, then it is very easy to develop the quantum computer. But we are working on the atomic scale. Just think about it. Electrons are dancing, not we are actually. And we are controlling the electrons or ions. So it's very difficult to how to control the electrons or ions on the atomic scale and still they are coherent. So the entangled system core is more than the sum of the part of the when we find out the mathematical sense. Now you have to understand some mathematical things and as well as physical things also. So this is a very basic thing. You know that this is a classical and the transistors are on and off. But in the quantum is like that. This is the electrons. It's a dancing on the half spin, plus or minus. You can represent in the both as well. It's not like the same. Okay? So, that's why the magnetic orientations. And poly-exclusion, you heard this poly-exclusion, is a very suitable techniques to actually map. But there is a many, we are not searching actually, we are targeting the exact mapping technique to satisfy the poly-exclusion, then it is easy to map with all the fields. But still all under researching. So it looks like that. It's a classical 0 and 1 two state, but then quantum overlapping with the superpositions. At the same time, all the qubits are like 0, cat 0, cat 1, cat 0, like that. So if you difference between the classical and quantum, there is a n state is a multiplier, it's a 2 to the power n supposed to be. And that's why this is the main reason. It's a multiplications and it's a exponentially grow. That's why the faster. Why the every time? What is the quantum? Why the quantum? So faster. Why? Because it's exponentially grow. Now how it looks like exponentially grow? Later on I should explain what exactly means exponential growth. So as I told the standard basis state. Now try to understand the state. What is the exact state? As I told, the two interaction picture. One is Heisenberg, another is Schrodinger. Schrodinger told we are not targeting on the momentum. It's very difficult. You all momentum is very high. Suppose it's not supposed to be a controlling your momentum, but I can control your state. I know that at what time you are actually the position. Supposed to be, I know. Okay, this man has this level. I can see from that. But it's very difficult to control this momentum because multiple questions came around this line, and momentum is somehow the three dimension. Ex, q, y, z. The state is somehow. So I can state the state like same like that. So all the classical qubits means the lie on the states or eigenstates, and it represent either cat or bra. And both are complex conjugates. It's not structurally always there. People are saying the cat 0, cat 1. You can also represent as a bra 0, bra 1. Just representation of the matrix. So, if you talk about the wave functions, how you can write the superpositions wave functions? So, cat psi is the wave functions. Alpha cat 0 plus beta cat 0. And I said the superposition is homogeneity and linearity. Alpha and beta is what exactly the homogeneity function. And this plus sign is linear. Is this quantum? No, it's a basics. It's not a quantum. Superposition always comes from the basic. And this whole quantum state lies in the Hilbert space. Now, what is actually Hilbert space? So suppose if you consider all your suppose I consider you all are energy state, and every professor has a own energy space. And this is true. C has another energy level, C has another energy level, means C has another Hamiltonian, C has another Hamiltonian. So Hamiltonian is what exactly? Hamiltonian is nothing, it is an energy. And the energy is same as the T square by 12 plus D. Means kinetic energy plus potential. So every Hilbert space has its own Hamiltonian. So see that. That's why all the quantum states are the Hilbert space. Now, I said the beautiful description of the matrix mechanism by Heisenberg. So they go, okay, let's define the matrix form. So cat 0 defines as 1 0 and this is 0 1. Okay, so if you put here and here, so what is that? Alpha and it's supposed to be mod nonce alpha square plus beta square. So that is basically the probability. And the total probability should be 1. That's why the quantum mechanics is a probabilistic mechanism. Also, quantum mechanics is a matrix mechanism. Okay. So, till now these are basics. And you have to also one thing understand. What exactly? What is the quantum postulate? Anybody? How many quantum postulate? Because before knowing behind that quantum postulate, we cannot pursue, we cannot forward to mind. And if you understand the quantum postulate, you will finish the quantum. This is basic. 5 साल लगे मुझे क्वांटम पोस्टुलेट को समझने में. And when I understand quantum concept, this is a quantum postulate. Then I complete a wrong method. So, as you know, what is a how many postulate? Can you? Please, it's just a conversation. Quantum is just enjoyment. Literally, it's not a tough task and not like a big. I came from the Delhi and totally like whatever the question in your mind, please ask. Because I also came here because I want to learn more and more about that. In quantum, many questions. Even when I am studying, okay, this, then I call my professor. Okay, every day. So, simply, if suppose yes, okay, yes, no, no, no. Quantum electrons has only two natures. Love or hate, hard and soft, yes and no. So we all are right now electrons. So simply, anybody? How many questions? 2, 3, 4? 4. And every postulate is basically define the path, define the system, define the process of the quantum. And today I will explain all the postulate, and after my completing the class, literally, whenever your professor is met from the IITs or from the ISR, met from the MIT also, you can easily connect. They can ask very easily, oh, this is okay, you are actually talking about this process. And after that, I will show you the block diagram, how actually. Okay, the same thing, we are quantum state. Now suppose you are considering these all the qubit. And if you are a Bob and Alice, Sarah, Samas, Eva, whatever the name you are putting, Gita, Sita, Gita, Ruby. And every name is a like quantum, energy state. The first postulate is talking about that coherent state. Coherent state. I'm just saying, and then don't be tension, there's huge slides and all, please. Here? Is it okay? Is it okay? Initially, first, coherent state. I mean, see, this is qubits. Right? The first postulate talks about the coherent state. Means all the qubits are coherent. First consider. Ideally. But it's not possible. Practically it's not possible. जब हम qubits को prepare कर रहे हैं, preparing the qubits, see quantum state preparation, qubits. We are considering all the qubits are coherent state. When we class we started that, we consider we all are coherent in time. जो मैं हूँ वो भी आ सकता हूँ, whatever time you are right now. Your knowledge and my knowledge is the same. Because we are coherent, we are pure right. After some time goes, now we are putting some impurities. You are disturbed after some time, and obviously you are not coherent. We are interactions. So, Hadamard gate, you heard the Hadamard gate? Yes. Hadamard gate, and after that many gates. Control gate, X gate, poly gates. The question, why only not Hadamard? Why putting the X gate, Y gate, control gate, CMOD gate? Why?
Transform the behavior.
But I am supposed to develop the quantum computer only for Hadamard. It's very easy now. 1 by root 2, 1 by 1 minus 1. And it's supposed to the tensor of the two Hadamard gate is unitary. You can see, I will show you that. The first postulate talk about the what exactly is coherence. Now qubit sensitivity. Okay, right? Now the second postulate, and think about it. Second postulate is evolutions. Okay, so evolution कहाँ पे होगा? Where is actually the point? When your qubits are inside the quantum system. In the quantum system. जैसे qubits inside there, they evolve. Okay, so the evolution is somehow we are considering this evolution is unitarity. We supposed to be this gate or quantum computer is unitary. Means when you are that approach. Now I am going to everyone. how to develop the quantum optimizer. Quantum optimizer. After 2021, there is another one more term is added. Classical quantum, one is hybrid. Now, this is a hybrid. So please, there is nothing going here. Just the D-wave is just manipulating all this story behind that, and they develop the hybrid quantum. This is not exactly the quantum. We are talking about the universal quantum. You develop your optimizer for universal quantum, not for the hybrid. The biggest drawback of the hybrid is they are not supposed to be the following with the multiple particle. When you come with the multiple particle, the heating effect generated, this hybrid water fade. And I discussed the D-wave, and they accepted. Yes, Kumar, it happens. So, बहुत सारे लोगों से discuss करते होता है. I talk with I want few people and all. And also, because we are engineers, we know that where is actually the. So second is evolution. And evolution, we consider this, all the evolution is unitary evolution. Unitary. And what is exactly meaning of the unitary? See this. I said the probability alpha square plus beta square, what exactly is sum of all the norms should be 1. Means this fact size is equal to 1. Means this wave function actually is the identity. Means unitary. Means this quantum system after evolve, they give always unitary matrix. Always. But due to the infinite dimension, due to the that, the major problem behind this. Okay? Major problem here, they did not give the unitary. Third postulate, measurement. Measurement. Okay? And people are actually working with measurements right now. Okay? So measuring these qubits is supposed to be unitary, but it's supposed to be non-unitary. How actually we can? So all these people are actually, the ISA or other scientists are actually working on this. Okay? It's very difficult to hear. So just they develop the quantum computer, whether it will be superconducting, whether it will be the NPATM, photonics, ion trap, whatever that, the measurement. Third one. So the first one is coherent state. All the qubits are considered to be coherent, means purely it's a coherent. Second is when you are putting the qubits inside the quantum system, they evolve. Okay. Second postulate is talk about the evolutions, and ideally we consider that all the evolution should be unitarity. Means after getting this quantum system, the output is should be unitarity. And third postulate is reason. We are extracting the information from the qubit and throw it. Is it possible to throw information after some time you are getting the same information? Like we extract at the time, having right now, and then after 1 hour you are getting the same information? It's not. And the pulse, the word term is pulse. These are also, we cannot actually extract the same information the next day. So they are also somehow they are working how they are extracting the same information in the main maps like that. So the measurement is there because the noise is interference and here. Like Alice and Bob who are actually ideal state. EY is summarized by this. Is a data. They interact, they interfere, and they actually they change the pure state to mixed state. And the mixed state is now the mixed is means you are actually measuring or calculating this the actual information that is result. And the last is composite system. If suppose right now individually here, if multiple quantum systems are working together. Okay, so three postulate is all this preparations, coherent state, evolution and measurement. These three are processed. Last quantum postulate is always its interactions, multiple composite systems. So anyone who is developing the quantum optimizer, you are just following this. So I am just showing this the qubits. System को दिया, but this system can understand only what exactly? Energy. It cannot understand any other things. Yeah.
Sir, is a quantum-based system Turing complete?
Turing?
Are they Turing complete system?
No, this is also not complete.
Then how do you, if they're not Turing complete, then how do you use a Turing complete language to represent a quantum system?
I said it's supposed to be all the coherent state is okay. The Turing computer is okay for that all the coherent. It's supposed to be coherent. If the decoherence occurs, means qubits are not actually the coherent, then the Turing computers are actually not working. That's why the Turing computers are failed for the quantum.
So the languages which are Turing complete, for example Python or C, they are Turing complete languages. So how do you code in a Turing complete language to represent a non-Turing complete machine? That's my question.
Yeah, actually all the virtual process are basically considering here the purest. Virtual, like FDPRAIT or the Python or supposed to be are just considering the qubits are purest.
So don't you think we require a Turing incomplete language ultimately to build a quantum system?
Maybe, but it's not like it's a different approach. And it's not like exactly the Turing computer to support or your real time when you do the computation. Okay. So how the quantum computers should be understand? The quantum computer should always understand that energy. Okay. I am talking about the universal quantum computer, the real time. What exactly you want to develop through mathematical. I said quantum is a mathematical field. I can help by how you can write your mathematical equation to build your blocks to support your mathematical algorithm to your Python or FDPRAIT or other simulators, and also your simulator is verified for your real time. So see, this is Hamiltonian, and this Hamiltonian can understand defined by this energy. So later on I will explain, and after that I said this is Dyson truncated, and then they are just comparing with this ideal is like a DFT discrete Fourier transform gate, or QFT supposed to be. You know that the quantum computer, normal computer can understand only the DFT, not BTF. Okay, because it should be bound. So that's why this ideal. So we are just considering the ideal. All the quantum computers should be identity. So we are comparing this using the Fourier's norm here, and then showing it. Suppose the error should be minimum. This our means derived unitary gate and already given unitary gate. If both are equal, means our quantum computer is perpendicular. So this is the actual model based on this postulate. Based on this postulate, and I said this is unitary means how it's unitary actually terminological because of this. The norms should be the sum of the norms alpha square plus beta square should be 1 for the matrix, and that's why the wave function should be identity or equal. This is the same representation. I said this a square b square, and if you talk about this, let's say phase, some relative phase, there's nothing but small phase difference, but if norms, the both are same. Because e to the alpha gamma is 1 also. So the norm should be magnitude is always 1, but the phase difference, relative phase difference between the two qubits is somehow is 9. That's why the block space, we saw the block space, I will show you later, that always there is some angles. All the quantum operations have to be reversible, and Boolean operations are not necessary. Sometime or it will be alright. And reversible operation is always becoming a unity line. That's why the quantum system is reversible. And unity means you dagger is identity. And how it will be identity? Just I am taking one example. Suppose you one of the matrix you not solve it, and you are just you dagger. It should be identity. You can change. So you can pick any of the like random matrix also, and you have to verify this random matrix and put it into like on matter or anywhere. As I already explained, this Schrodinger is a mainly accurate describing interactions, and why all the research is focused on this, time dependent or not time dependent. And this is the basic equations where people are struggling. This is a Schrodinger wave. Iota H dagger, then certainty is equal to H psi. And what is the H dagger? H dagger is a reducible Planck constant. You just consider this H dagger is 1. So del sub del T is equal to minus IH. H is molecular energy. Okay. And now you forget about this Schrodinger picture and whatever that. This is a simple differential equation. If you solve this differential equation, what is that? Psi is equal to e to the power minus IH T psi. Simple. And as initially I defined the mathematical framework, and that mathematical framework is described by wave function. So e to the power minus I h t is nothing but it's a wave function. अगर आप इसको चेंज करो e to the power minus I theta तो cos theta plus I theta. The same, this is a wave function, and the wave is electromagnetic wave or somehow is like that. So the quantum system interact in the three ways, either magnetic, either electric, or electric. So as per my definition is a mathematical framework, and that mathematical framework is like a wave function. How it is a wave function? When supposed to be solving this wave function in this differential equation, you are getting this e to the power minus I t h and then sin initial, and you are just with this cat. So now you can define cat psi is equal to e to the power minus I h t cat psi. And just replace, you are considering, I got exactly, and then you put this wave function into the quantum system. And as I described, the second postulate, what exactly is evolution. So this wave function evolves, and ideally, after evolution, what exactly will be unity, right? So this wave function psi is converted into u. If the notation is u, so u is equal to what is e to the power minus I h t u. Simple. Rest all of this. If you understand this equation, you can explain, you can write any of this optimization. Because the basic things is not a second order, third order, whatever that what you are just try to understand how this wave function converts into unitary. Okay. So these are just not related. So explaining the E and H, again it's an item, it's energy and Hamiltonian. The same Hamiltonian is energy. That's why this whatever the energy is equal to, supposed to be is equal to V, the same is like that. And T square is momentum, explaining describing speed in terms of the delta, just like that. This is the momentum and this is so it is actually same like that. Yeah.
So what I understood is that we are having two ways. Two ways are nothing but they are basically energy, having such an energy. And all we are assuming that all are correlate. Okay. Then we are putting these quantum bits in the quantum computer. So they are evolving and final output is becoming bigger. The thing is that what is happening inside the quantum computer, because of that, they are becoming bigger. That is first question. And then afterwards we are measuring. So whatever information we are expecting, and that is our output of that quantum system, quantum computing. So basically, suppose I want to perform an operation, that operation will be some algorithm which will be performed in the quantum computer, and the operation will, that output will be getting as the operation result of that operation, right? So my question is that every time with the output, as you said that every time whenever I am measuring, the output will be changing, right? Output will be changing, it will not remain same. But whatever operation I have written as an algorithm in the quantum computer, it should give me same output. So these are the two questions, how the things are done, what is the reason, what is happening?
Here I am explaining about how the qubits are basically connected to your energy. I mean
Yes, they are energy, these are energy, and we are putting these into quantum system. And then you say basis, we are running n dimension basis.
Right.
Then we are performing some truncation so that we are running for a particular time domain, for particular dimensions we are getting the output. Now thing is that quantum algorithm, quantum system is basically performing some operation. So what is that operation? That is my requirement, right? मुझे जो भी करना है that requirement I will put as an algorithm in the quantum system for computer, and then it will give me an output. Now, suppose for example in operation, for example, I have to do some search operation or to find the maximum operation or whatever. Now, you said that every time when you are performing the operation and I am reasoning it, so it will not give the same result, right?
When it will be, it's supposed to be in a pure state, then it's the same.
If it is in pure state, but it will not remain, right?
Yeah, that's
So
why
that's the problem.
That's why I'm saying. That's why I'm doing the picture. I said unitary, but it's right now I'm describing about pure state. If it will be the mixed state, what exactly the equation should be and how the result performs.
Mixed state is because of the interference in other
The
things.
other things.
Yes,
Right.
yes.
Interference.
So that will be always there. That is not in our control.
No, we can control. That's why we can control.
So how is the interference not in our control?
Yeah, that's what I'm explaining about. It's suppose that it should be not unitary and the noise is coming. Then how actually about the wave function actually or this wave function is representing some u or some other thing. If it will be the mixed state, then it will be like a density operators. And then you are actually extracting the information through the Von-Neumann drop. Not the Shannon drop. Shannon drop is failed because of that reason. Because they are not supposed to be calculated in the mixed state. Okay. So in a pure state, the trace of rho, I mean that is the density matrix, is also the same like in unitary. But when the two systems are interference, one is the noise and one is the ideal, and then mixed state is coming, then how it will be actually calculating, or how to calculate the measurement process is actually performed. Then this is the second step one is actually to my next slide is doing what exactly process we can calculating the measurement process. If suppose the noise is coming, every time I set up, if ideally the measurement is what exactly is, whenever we are measuring the information, the same information. But if the interference of the noise, every time the noise is right in the system, information is changed. So how we can minimize this interference or noise or error? To minimize the error, we are extracting the same information what exactly is.
So that is the basic logic of communication in general.
Yeah, in general.
Whenever we are transmitting a number of bits, some noise and interference are there, then at the receiver side, we do the same operation, right? We try to remove the noise and interference and then we get the same information. The exact whatever was transmitted. So same concept we are using here also. But my question is, what is happening within the quantum computer? Because of that you are saying that it is evolving.
Right.
That question is not, that answer is not clear to me.
Yeah, that's what I'm
Because
saying.
that is in quantum computer we are
That block is being jumped just explained about the postulate.
Okay.
That block is explained by that block is how the postulate. Try to understand that this is the postulate is like
Things are clear.
yeah, postulate is it's not sure all your postulate is performed perfectly.
Okay.
This postulate is ideally okay. The first is this, second is evolution is unity, third is measurement, and fourth is this. But when this ideal, the postulate is some when you started, this is postulate. But when you go through and then you understand okay, this other system performing some is perfectly because now it's an infinite dimension, also noise and interference in atomic scale. How it can actually perform, and when it will not be the unitary, then how it will represent this unitary matrix. Okay, so I started, that's why I explained about try to understand the first Schrodinger, what exactly is mathematical. Ideally it's a unitary, just consider it's unitary. Now next level I will explain in my slide also. It's supposed to be it's not unitary. How the measurement process perform and which tools basically utilize. I did that and I found.
It's not unitary because of noise and interference.
It's a
And
pure
evolution process is something different.
something. Okay, so I explained this. So I said, it's suppose we put in the quantum system, change the wave sign to the UT. And this is the ideal initially, just forget about this. What is that? This is H0. H0 is an unperturbed Hamiltonian. Unperturbed means, if suppose we are standing, there is no movement. At that time, what is the energy? And that time the energy is the same like T square vector plus B, and you are just considering this is uncovered. But when any ball or electrons move and small disturbance come into the picture, this is the size and nothing is the disturbance, then what is exactly the potential? So we are just considering this H1 initial Hamiltonian, and this is the perturbed Hamiltonian, means after some time at T1 T1, what is the energy level? So sodium always talks about the atom state. Initially is E0, E1, E2, E3. The same like alpha, epsilon square, epsilon cube, and this is very small perturbation, small disturbance, and the energy state change. And this is the process how actually we are explaining this. So before that, so how any quantum system can be actually performed? Whether it is superconducting fluids, whether it is ion trap. So if suppose you have a Hamiltonian of any quantum system, you can write any of the wave function of the any. Use this Hamiltonian in the tail. Right? So this is what exactly is H. So my concern is to quantum system is what exactly? Try to find the Hamiltonian. Whatever that. If suppose I am a quantum system, find out what is my Hamiltonian. If on the Hamiltonian of my, then you can do this. Because quantum system only understand this term, Hamiltonian, means energy. And if you define the energy in terms of this Hamiltonian, then you will easily perform your quantum system. And this H1 is always a small disturbance. It means you are putting the perturbations H1, H2, H3, H4, so on. Okay, so I am just explaining what exactly is the magnetic field interactions. I said always is interaction. Interaction means I said it's the same like that. I just Heisenberg interaction or Schrodinger interaction. So I use mostly the Schrodinger interaction. So obviously because it changes the energy state from E0 to some other thing. Now, as if the question is, now suppose my quantum system is developed for the coordinate system. Now the Alice and Bob is ready to actually transmit the information from one channel to one level to another. It means transmitting to receive. So whatever the same, in classically you are using the same like modulation technique you are supposed to be the classical modulations, or actually it's a program either classical frequency or the phase or some other amplitude. AM, FM, KM or some other in digital is some different. The same idea in quantum also. We develop the quantum receiver, but the question is how to develop the quantum channel. Okay, I complete the paper on the quantum receiver. I develop the quantum receiver, but I use the CQ channel, classical to quantum. I never use the QQ channel, quantum to quantum. Information is always classical. My voice signal is always clear. What is that? It's a classical. Now my voice signal is putting into the mind and transmitting to the quantum channel. So my next research area is I proposed this and submitted this proposal to DST, and we are waiting for it. We developed a quantum Schrodinger channel. Means QQ channel. Means channel B quantum and receiver B. Okay. So how the quantum channel should be developed? The question, because noise or interference or whatever that will come into the picture into the channel. Receiver is also detecting the receiver, but the main target is the channel. When the Alice is transmitted some information to Bob, the EY is actually sitting on the channel.
So channel, what is the form of the channel?
Channel is anything like wireless, whatever that. Same like that.
Wireless, wire.
They are already developed and they are proposed to be the QPD channel, quantum key distributions. They use that. QK. Yeah. They use. But there is a one institution.
Keys, sir.
Key. Yeah.
I am asking when we are transmitting these qubits to the medium, I am talking about medium as you are saying, the quantum channel. So what will be the channel?
That's why I am telling you. What exactly the DRDO proposed and what exactly I proposed here should be different. We are also targeting how the quantum noise should be targeted. DRDO is not supposed to be the target of the quantum noise in the channel. Okay? They are just using the key distributions and they are just transmitting the one qubits to another qubits. not supposed to be the test capacity. It's far away from this. Get the point. So just considering, here I use what exactly is rho. First time I use rho. Rho is a density matrix. Suppose the mixed state occurs, means pure state violated, and a mixed state occurs, then how to write the same wave function and acting the same wave function is another immediate. The pure state, it happens, but in that mixed state, it's not. It failed. And that's why I said, my question is, why only Hadamard gate now? Why they are putting the multiple quantum circuit like Hadamard, control, Hadamard, poly.
So in order to get the original state, what is it? Coherent state.
Correct. So two things. Here I am also, before describing this row, there is a two type of system. One is separable, another is non-separable. Before coming here, you are a separable. Okay, you are. But when you came here and I started interaction, now you are not a separable. You are a non-separable. Because you are interacting with the Kumar. And suddenly, your amplitude is interacting with some other potential, you lost your separability. And Hadamard gate is a pure separable system. And I said, if suppose two Hilbert space, I just suppose consider one is H1, another is H2. And two Hilbert space are interacting each other. Ideally, what exactly is the tensor product? H1 tensor H2. Suppose you all are same state right now, all are separable. So you are interacting again. Kumar is coming from Delhi and all. You are separate, and you are ideally you are in me. But when I enter, you are interacting with me.
So your liberty space in our this is H1 and that is H2.
My potential, your potential interacting with me. Now what is the Hamiltonian or what is the exact Hilbert space? So H is the same. H1 tensor H2 plus V12. And when the some potential term added into your original state, and it lost the separability. So that's why the Hadamard gate is not possible to define when the interaction picture will come. Or other, as I said, EVA is interacting with your, EVA suppose, so it's interacting with your pure state, they lost the separability, they lost the purity, and then they are basically acting as a mixed state. Now the same thing. Now before that you are writing the wave equations in the form of U. Is it possible we can directly, previously what exactly said, you just directly you can put instead of psi, you put U, and psi is equal to e to the power minus IHT psi naught. I said just put into the replace the psi into the U. So what exactly unitary is? U is equal to e to the power same, e to the power minus ITH naught and U naught. But is it possible the same you can put this rho in the same way in the next step? No. It's not there. Because when the pure state, this trace of rho is a unitary. But when the considering their interactions or coming to the mixed state, then it is not acting like that. So how to write these equations? The same wave equation and to justify this your unitary matrix, it's a different. And we are using the quantum stochastic differential equations for that. Using the one entropy explanations and then later on is just. So now suppose this is information. I and number of, and the P is like a pulse. Simple modulation is just looking this. I is information is just like this. I and P is simple modulation. The P is a pulse and 1010 and into multiply into V. But exactly the quantum system can understand only two things. One is the Hamiltonian, another is the state. And so modulate with the V and add it with your ideal Hamiltonian and defining the total energy. And in one qubit or somewhere. So in there we are actually finding the entropy. It's not directly we can find this the same like the wave equation or defining. And this entropy is basically, entropy means what exactly? Average information. So during the measurement side, we are actually calculating the rate of change of entropy. And if the rate of change of entropy should be minimum, means you are supposed to be the approach is to be made. So the target is the rate of change, the growth of the rate of change of entropy should be minimum. So in two pictures, whatever the simulation you are using, and QSK or Quasar or anywhere, they are not supposed to consider it. Because mathematically we have to. Why the quantum computer still not coming into picture? Why? Almost 123 years completed, but still people are struggling. I am also struggling and trying to find the solutions. How all the qubits should be mapped. अगर कोई ऐसा टेक्निक आ जाए, all the qubits should be mapped. What is this entropy? So very easy, ना? करना क्या है? Mapping means coherent. When they are putting in the quantum system, तो mapping हो रहा है. And if it's not happening, they lost this. During the measurement, every time you are fast. Getting this, next time, information stream because of that. Next step. So the people are trying to find this. One technique is, you can also search it, something like that. I will share you. There is one MIT professor, they are supposed to be started. The two things is, one is the spectral decompositions, and another is poly-exclusion. The two approach, they are trying to find this, the qubits map. And it is supposed to be the qubits map, and it is easy. One more technique is now, in South Korea, I found the cluster decompositions. Means suppose if you all bifurcated into 5 clusters, and each cluster are like qubits. So if supposed to you are minimizing the qubits, then you can also approach it. But you are increasing the qubits, then it is very difficult to error repetitions. What exactly the IBM are also facing. IBM are claiming that we are teaching supposed to be 433, but if you talk about the error medication, they are supposed to be 127. And IOQ is somehow is 80 or 20 something like that. So in India is also right now they are 10 qubits or 11 qubits. They are some of the professors, some of the scientists, they are working on this. RRI from overseas Sina, she is also claiming that we are working on this somehow the QPC. Some IT professor is some professor is QPC founder. She is Punjab. She is also working on the photovoltaic. So I remember, so how to get this trace of it? So this is small mathematical equations, just like defining this. If you want to work on the communication channel or supposed to be security side, start working on this. And what is the theta? Why I put this here theta? Theta is nothing but it's actually the observable. See, in the mid state, there is some observer. And they are some observing how what exactly the solution will come. So we have also this density matrix is also depends on the observable, and this observable basically is directly correlated to your entropy, rate of change of entropy. So if supposed to be this observer, rate of change of entropy should be minimum, observable minimum. If suppose this minimum, the rho is also minimum. After is so you can work on this. This is totally open area. Right now people are working on this side, and so coming to this last, how to develop the quantum gate or quantum computer or quantum computer, and which software we can use. Okay, it's a very big like that. There is 3 techniques. Either you can use the cavity. Second is like more utilization of electron spin and interaction. What exactly the people mostly I also use this electron. And third is basically you can use this quantum box or some of the electrons whole sphere. And what is and this you have got the whole price. So you can choose one of the 3 major areas. It doesn't matter you can whatever that. The cavity somehow you can develop this the radar atom. You are putting the ions in the cavity and build your atoms, and then but it is again. But somehow it's very difficult how this atom can transmit your qubits and all. So this is my final. This is a control gate. What exactly I said. If you want to develop the control gate, this is the simple block diagram. First, you have to develop unperturbed Hamiltonian. This is the same P square by 2m plus V. After time t is H1. Merge with the total defined because quantum system operation can understand only for Hamiltonian. So whatever whenever you are starting quantum, first you have to understand that this H. If you understand this, what is the exact H, then it is easy to understand the quantum system operations. And after operation, because as I told that this is the infinite dimension, so we have to truncate. After truncations, what exactly? This is just this UG is basically ideal quantum, whatever that is, you have to compare with that. So after truncations, you have to compare with the ideal to derive, and this is a cost function, and this cost function. So now, whenever you are developing the quantum optimizer, the same law is always. Now this cost function you are putting here either quantum GA, quantum GSO, PSO, BHO, black hole, whatever that optimizer. I developed last 2 days before I published one paper is I developed transitions, we got 10 seconds, and I developed quantum path integral approach for VR, very important problems with limited qubits and they accept. So whenever you want to develop a quantum optimizer, whatever that, the process aspect for universal quantum computing, you have to remember, don't be confused. For hybrid, its block is different. I am describing here for universal when the real quantum computer will come into the picture. This is exactly the block diagram to understanding to how whatever you are. It's supposed to be you want to develop your QG quantum theoretical. So your QG is basically depends on your cost function, and your cost function depends on your unitary, and your unitary depends on your action, and your action depends on your unperturbed and perturbed. Means action. So this is the basic block diagram, and you can write on your this, and I suggest you can use either QScript or Twice also QSM. Okay? वहाँ पे you can write very simple. If suppose you know the Python, very good. If suppose in I don't have idea about the Python, but I want to invest, I have interest, I want to develop a quantum circuit without knowing the Python. Is it possible? Yes. It's a reverse issue. You have to develop your quantum circuit, whatever that, and to extract your quantum circuit as a Python code or whatever that, there is one. You can write a quasar, you just go. It's a very easy toolbox. I mean, in IBM is also okay, but my suggestion is you can use that. Amazon bracket is also, now Amazon bracket is also, as very good things is, your MATLAB is supported to your Python. If suppose, like I am expert in MATLAB also, now I am Python also. But before the South Korea, when I joined South Korea, I was more expert in the MATLAB. But the question is how your MATLAB converted into Python. The Amazon bracket is supporting also. You can convert directly your MATLAB code into Python. But my suggestion is you use directly Python. You build the circuit and develop this.
Sir,
Yeah.
previous slide. So in quantum operation, there is a state, the state is real. So we are giving
Yeah.
These are in-between states or what is that?
This is the quantum operation. The qubits are here basically. See,
You are
writing the
actually.
when you are writing the mathematical part, you can write this. Now, action is basically describing
So
your
that is the representation.
representation. Right? When you start the math, what about the quantum? To write the first mathematics. How to write the mathematics? To write first Hamiltonian. Any the Hamiltonian is ready means you are actually the
So this
every
is
qubit. Yes. Every state lies on the Hilbert space, and every Hilbert space has own Hamiltonian. Means this H. Every Hilbert space has own Hamiltonian. If two Hilbert spaces are interacting, means the tensor product of the two Hilbert space. H1 tensor H2, and if interacting each other, then B 1 plus. So this I already explained. I developed this QGSA there. I said that you can also develop any quantum optimizer. And first time I actually explained, I actually showing this what exactly I did in South Korea. So you can also use this. And see, here this block diagram, I am explaining how the mathematical things and your optimizing your simulators, QSpeed or suppose how actually it works, you can actually implement that. So here you can develop your optimizer. You can choose whatever the optimizer you are. Quantum optimizer. See, if quantum optimizer means first quantum operations and then your optimizer is supporting your quantum. Not like that. You first optimizer लगा दिया and then उसके बाद we are putting developing the qubits. That is a hybrid. In a hybrid, what exactly you do? First optimizing, and then whatever the values is coming, each values are containing the qubits, and then they are putting the quantum circuit, whatever the circuit they are planning. So it's not like that. It's hybrid. If you want to develop the quantum optimizer, you start from there. You can change this. I'm not supposed to. You can also do the Frobnius norm. I use the norms. You can also suppose this is a cost function. You can choose any of the cost function. In present, many cost Probel and other cost function is also there.
So for this optimization, this equation, that is this part, this gate part, which part gate you are choosing? Hadamard gate?
Multiple gates.
Combination of gates.
Combination. I said that Hadamard gate is a good product.
So
So I developed.
So that circuit can be our choice. It will be
Yeah, you can.
So for that particular circuit, it is the optimizer. Whatever optimizer.
I developed.
Because that optimizer will not work for all the other combinations, right?
Right. Here you can use this quantum circuit as per your
Our design,
Yeah.
how to use our circuit, and for that we will be designing a optimizer.
So start from the 2 qubits or 3 qubits. Start from the 2 or 3 qubits and develop your quantum optimizer. Starting from the GA, very easily you can get the Python code of the GA. There is no any such QGSA code because I am not saying anywhere you can because it's a Hyundai. We signed the contract with the Hyundai, so I never said this code or all. But I am just saying this. This is actually the things where you can understand how actually you can develop the quantum optimizer. I developed another optimizer, QPI, and third is QBHO, quantum mapping optimizer for maritime cargo. So these are actually the things. I will say you can go through. I developed the quantum this paper published, and control unitary gate. I shared this 3 qubits, and also I shared this. This is the matrix. How you can also develop this. That's the aspect. So this is actually the methodology. You can work. You can choose this one and write a unitary matrix, and you can understand. So start from the 2 qubits, 3 qubits, 4 qubits. So I will share to you. You can please share to anyone, and they can understand. They can develop the quantum control. So this is the last. Why it is? Because this is usually two sides. 1, 1, 1, 1, 1. All the upper and lower triangle matrix should be 0. Just we have to manipulate here. And I verified, you can go in my paper 2017, I verified that this also is different. And I developed at that time, it's a matching generator, it's a new technique, and I am trying to use these techniques too. Now, every time question is, nobody are talking about the NSR. Actually, here is not NSR, here is NSER. So that is okay. Okay, it's almost. NSER. Why NSER? Noise to signal energy ratio. Okay. In classical, what exactly is? Noise SNR or NSR. Whatever that. Power. Okay. Noise power, signal power, or signal power to noise power. Here we are not talking about the power. What exactly we are talking about? The energy. That's why this is NSER. And NSER first time BS actually started. Nobody actually talked about it.
It's because we are interested in time.
What exactly the NSER? NSER is just performance criteria to verify. NSER, it's supposed to be your exponential decay should be 0, means your job is done. Noise to signal ratio, it should be minimum. So I propose that it was also, I suggested you can cite, you can go through this paper 2017, the matching generator, develop the quantum control rate specifically for ion trap also I have this. And I developed this with this NSR. So whatever the paper I am writing, always I am checking my performance criteria whether the quantum system is performing work perfectly or not. And and it's supposed to be exponentially decay and reaching to the zero.
All other authors are also using this NSR or only you have used?
I use only. I and yeah.
So is it acceptable? Because
I define that.
because then the reviewers will ask you ki whatever.
Anytime ask, I define and they accept.
Okay.
Yeah. And that's why it's published. Okay. So many software tools are there. This I suggested. I never mentioned here is Quasar because recently I did. These all are companies and this all this company and there's so many simulators. And very soon the CDEC also will develop the simulators. And CDEC and QS has signed an MOU the last 2 months before, the 26 crore project. And we are also planning to working on the quantum machine learning, some different applications. The people are one is security, another is intelligent transportation, and third one is health. So if supposed to be anybody interested, we kindly just invite you to work. This is this basic matter about how you can like develop your animal or suppose a Benz. I will share it with you. This is initial actually when I was working, and now I will also share some Python code. See this one actually forecasting is a very old graph, but see how the quantum is basically everywhere. Any area presented. Whatever the area you started, just put the Q and now the agriculture, whatever the automations, anyway. So this conclusion and nothing. I just describing the Q race. I started in Q race 2019 and yeah, I received a fund from the AICT about 30 lakhs initially after 3 months when I started my journey. And then we will COVID and some everybody was at that time stuff. And then again I come back in 2022 and I got some funding or some from the government of Bihar. At that time I was in Bihar. And but the Bihar government did not accept the QRACE identity because the QRACE was in Delhi. Then I started some different startup that is named E-Green Quanta. And the E-Green Quanta is more concerned about the EV industry. So I developed some different, like other than quantum. Might be possible, supposed to be the replace the lithium ion. It's a lithium graphene paper based battery. So I started the graphene is also one of the material you can develop, you can work on this, and you can choose this graphene in anywhere. It's very easy to extract it. I mean, graphene coming from the the waste material, and scientists are also working on this side. So this is a superconductor. So I think in future, probably maybe or me or man or QRACE or some other, they will develop a quantum computer based on this material. So these are 3 targeted right now. What exactly we are working? One is obviously this quantum control kit. Still I am working on this. Second, my goal is to, as I saw the solution. And third is we are planning to develop.
So, can you give some idea about quantum antenna? Because I am from that field, communication. So just would like to about actually what quantum antenna.
Yeah, see, this we are matching this basically. We are not exactly we are putting a name like DRA or something. So if suppose your antenna is far beyond this gigahertz to some above the gigahertz, this concept is basically supposed to be quantum, because that's why we are putting this quantum antenna.
Above gigahertz, so millimeter waves are there.
Yeah. So here we are actually using the graphene. Suppose graphene based antenna. So we are putting this graphene based antenna is quantum antenna because graphene is superconducting material. So that's why. And using this graphene and quantum dot, we are trying to merge these two. So right now we are just under research area, studying that. Some of the NIT professors, they are collaborated with me because they.
So basically the concept of antenna is to transmit, to radiate something into phase. So here we are planning that using this antenna we will radiate qubits.
Not very obviously qubits are not transmitted from one person to another.
Yes,
Like interaction is like electromagnetic. Same
okay,
like
by the process of it.
Yeah.
Okay.
Like quantum is also like a wave functions.
Yes.
So these are like goals forecasting how we can start some material placement. And this small announcement, the last 6 months also, I started a remote access when I was in South Korea, small intensive program in QRACE. But right now we have also more opportunities in CDEC because when the CDEC is signed to the MOU, so CDEC is also opening in Noida right now. for internship program, and in QS also, and it's also paid. It's paid means you get a scholarship. It's not like a free, something like that. And both physical and this time, last time we are just connected with this. This time, last time we are working, we had the internship for maritime cargoship, because I have small announcement. QS is also signed very soon. We will sign the Quantum South, the Uruguay is base, and they are working on the Airbus as well as the maritime cargoship. So I associated with the maritime cargoship. So my students are right now working with maritime cargoship. This time I am concerning about the quantum communication side. So I am looking at machine learning, because the CDEC is also somehow is interested in looking the QML expertise or internship, or if supposed to be anybody are interested in the job, master or PhD, that they have also.
Paid internship?
Yeah, the CDEC also will give the scholarship and QS also the same scholarship. So this time it's a 1 month, but CDEC is a 6 month. For me is 1 month, CDEC is 6 months. In QS, 1 month is internship, and CDEC 6 month internship. It will start from January. So it's supposed to be anybody interested or somehow is interested in the QML side, okay, directly send the CV, I will directly forward to the director. And without any long process and all, you will get that. It's supposed small match with some of this. Because you know that they are looking the QML expertise, and you know that there is no way right now, the people, not me also, we are also in the journey in a new way to start it, and to initiate the collaborate with the main professors and to work with. These are my partners, right now working with the main partners. And so, Mr. RAIT-ACM and we are signed. Another announcement, small announcement is, thank you. As you heard that RAIT and MSF, one proposal is already right now is open. The last date is 5th of Jan. It's suppose if anybody are interested, I will share the proposal. You can share it. And if anybody are interested, the condition is you have one collaborator from the US. If any professor have a US collaborator, they want to work with you, I will introduce the CDEC directly to your institutions. Okay, so obviously me also, I will be there. The CDEC, your institution, and this. If anybody are interested. So still we have time. I mean, not so much. The last date is 5th of January. So the question is, if anybody are like, we receive the assignment already. I got also a consent, and the CDEC is now looking at 5 proposals to collaborate with. And the funding opportunities, RAIT will give the fund. Obviously, they have a huge funding. So you have to start in there. I will guide you also somehow, whatever that. The area is security, health sector, and intelligence and transportations. Okay. Because why I am putting this? To forget about the health sector, at least you start on the security side and intelligence. Because recently, and the next, maybe probably next year, in January, railway government also will announce to routing problem of the, and they already, the honorable minister, they announced this, the quantum computer will introduce the railway side. So I am targeting, I am right now looking at like opportunity to railway side. It's supposed to be, I will get the opportunity from the railway government. I will contact you to collaborate with the people and to work. Thank you.
So thank you for sharing for all your knowledge, wisdom, expertise. To summarize what we have learned in this session is, Sir has started with very basic things like what is the meaning of micro. He has talked about different types of optimizer designs and like AQGSA, QBI, like Q black optimizer. He has also given us a very basic difference between a classical circuit and quantum circuit. So what all we have been learning from past few days, Sir has definitely given like new dimension to an understanding of quantum computing. Also, he has talked about the methods and methodologies and models of how to design quantum controlled gate. Then the classical signal to noise ratio and what evaluation of the quantum circuits and quantum technology. Sir has also given an insight into what all companies we have, different software development kits, and then SDKs, that is, and the companies along with their simulations, like we can work on QSK or CASM or QSM. And thank you very much for sharing your work. Like, I guess Sir has given us many research directions, those who are planning to go into quantum computing research. Sir has highlighted various dimensions, particularly security, intelligence, and healthcare. And so thank you for sharing the internship details. Not just that, Sir has shared us who all want to work with Unity and their research projects along with CRAP. Sir has also given directions in that. So it's all a win-win situation for all of us. So it's up to us to grab the opportunity and go ahead. And so, all the best for the FDPRAIT's goals. We all wish that you achieve all your significant goals which you have planned for the next year and the future goals as well. So, with this, we would like to come to an end of this session. But before we end the session, a small token of appreciation to Dr. Kumar Gautam. So, I would request Mr. Sanjay Chandani from RISET to hand over a token of appreciation. Most of the questions he has answered in his presentation. And thank you once again for sharing your expertise, sir. I guess what work you have done, it is something which is inspiring for